No, she get this, and I'm pretty sure that's that. Yeah, make sure.
Okay, so we're gonna go to 3 variables, 3 equations. Okay. Before we get into solving them, I want to talk about what it means. Okay. When we have linear equations with 2 variables, we're in a 2-dimensional plane. They represent lines. When we have linear equations with 3 variables, that means we're in 3 space. And so a linear equation represents a plane. Okay? A linear equation represents a plane. So, what is our possibility for 3 planes? You can have a line as an answer.
They're all parallel and they don't touch.
We could have 3 parallel planes that don't touch. Well, let's talk about planes. Okay, yes?
You could have 2 planes that are the same plane and then another one that is out there.
Okay. What else? Could 2 intersect?
No, it's not intersect.
And like there could be 2 that don't intersect, but 1 that intersects the 2, right? Well, let's look at some pictures. Most simple, they could intersect at 1 point, and that is what we're going to see the most. We could intersect at 1 line, which means there would be an infinite number of solutions. They could all be the same plane, and then we would have an infinite number of solutions. They could intersect, but not all 3 simultaneously. Therefore, there would be no solution. Or they could be all parallel, and then that would be no solution as well. These pictures are in your book. Okay, these pictures are in your book. Don't feel like you need to try to draw these, okay? These pictures are in your book for reference, okay? We will look at this mostly, which is what you did last year, but I'm also going to teach you what this situation looks like, okay? And of course, we're going to work with word problems, okay? So we have 3 examples for today. Write it down. Okay. You have proved to me that you are very comfortable solving a linear system with 2 variables. That's what you did yesterday, minus the problem that we did for the problem of the day, okay? If you have 2 lines, you are very good at finding where they intersect, okay? So if we have 3 equations with 3 variables, if we could somehow eliminate one of the variables and get it down to 2 equations, 2 unknowns, we're very comfortable solving for that, okay? So what we're going to do is we are going to pick one variable to eliminate twice. That way we can get down to 2 equations, 2 unknowns, okay? It does not matter which variable you choose. Some people will choose different ones. If there's one already missing, that may be a good one to choose, all right? Does anybody have a preference on which variable we eliminate?
I'm thinking you should just eliminate y and z at the same time. It'd be a really easy solution.
Or you can just multiply the bottom one, the last one times 2 and then
Maybe think you should add the bottom.
Okay, so a lot of you are like seeing all these different things, right? Let's just pick a variable first. Z,
Eliminating something.
let's eliminate Z first, okay? So, a lot of you are noticing this right here. The Z's are opposite, correct? So let's take the second equation and the third equation and use our elimination process to eliminate Z. So the Z's cancel. Oh, so do the Y's, don't they? So 6x equals, oh, Mrs. Holman.
You still get X up here.
You, I still would have got the same. Okay, 5x equals 5. Okay, so I know that we could keep going, but I'm going to highlight this. Okay, this is me highlighting it. We're going to come back. All right, now we need to do this one more time. Let's pick two different ones. Okay, the first one and the third one, those are already opposite. We don't have to do any work. If they weren't opposite, we just multiply either one or both by a well-chosen number so that we could make them opposites. Okay, so we eliminate Z again to get 4x plus 2y equals 8. Okay. Now we are down to two equations and two unknowns. So what we are going to do is we're going to take these two equations, solve for x and y, and then worry about z very last. Okay? So this was really nice, and this isn't always going to happen, but x and y eliminated here. Okay? So what is that? There it is. There it is. X is 1. Okay? So now, okay, going to highlight that. Now we're going to come over to this equation. Okay, don't go back up to the top until you have two variables accounted for. Going back up to the top is not a good idea. Here, we still have two variables. We can plug x in here. What is what? Okay. Now that we have both x and y, we can come up to the very top and we can choose one of these equations to plug 1 and 2 into. Ah, you guys can see that. Okay, the first one is probably the easiest to plug into. What's nice is these don't have coefficients. If the variable that you're solving for, if there's one that has a coefficient of 1, that's the one to choose. Okay, so x plus y plus z equals 6. So x plus y plus z equals 6. What is z?
3.
So your final answer. What an answer. 1, 2, 3. You need to write it as an ordered triple. 3 numbers, ordered triple. Okay? Now, do you know if you have the right answer or not?
We can find out.
You do know if you have the right answer or not. This is a solution because it works for every single equation. So, is 1 plus 2 plus 3 6?
Are you amazing?
Okay. 2 times 1 is 2. Minus 2 is 0. Plus 3 is 3.
Yes.
3 times 1 is 3. Plus 2 is 5. Minus 3 is 2. It works for all three. You don't have to show me that you checked it. But on these problems, you should know whether you got the answer right or not, because it should work in all three equations, okay? And even yesterday, I didn't do a very good job of telling you to check your answers, but you should verify your answers to make sure you got the right answer. Okay? Questions? Okay. Here's my warning to you. It is very, very easy to miss a negative or add incorrectly like I just did or mismultiply something, okay? You need to take your time when you're going through these problems so you don't make a silly mistake, okay? Most of the time, you know how to do the problem, but you get the wrong answer because you make a silly mistake. So do not rush through these problems, okay? I'm not telling you that fractions are bad because fractions aren't out of the realm of possibilities, but make sure you are careful so that you don't get all the way to the end and have to go back and redo the problem or search for your mistake. All right, we have a couple minutes before lunch, so I want you to at least get this written down. I'm hoping we might have time to get our midterms back today. If we get done in time, we'll look at our midterms. All right, so this is what I noticed about this problem. The second equation, what's missing? A y is missing. Since we have an equation with a variable already missing, it would be a good idea to choose y as our variable to eliminate twice. Okay, so we already have 4x plus 2z equals 10. Okay, I'm going to just highlight it here. Okay, you don't have to box it, but I like to, so I know I want to come back to it. Okay, and now we're going to take the first and the third and eliminate y. How are we going to do that? We need to multiply the top one by -3. So we have -6x minus 3y minus 3z equals 4. -2x plus 3y. Okay. So, yeah.
It should be a plus 9z on the top equation.
And that, ladies and gentlemen, is how easy it is to make a mistake during these problems. You get going, and you forget you're multiplying by a number, okay? So now when we combine these, we get -8x. Our y's cancel out, that was our goal. Minus 4z equals -16.
-20.
-20, my goodness, Mrs. Coleman. Okay, you're just going to tell me all the numbers from now on, okay? When we get back from lunch, we will continue. Alrighty. So we eliminated y twice. It was already eliminated in one, so we only have to do one. Okay, so now we're down to our two equations, two unknowns. Some of you can kind of see what's going to happen. Okay, what should we multiply this function by? We can just multiply it by 2 to get 8x plus 4z equals 20. What happens?
Everything cancels.
Okay?
X.
So this means infinite solutions. Okay? Now, we can tell up here that we don't have 3 of the same plane. Okay? If we had 3 of the same plane, we would be able to tell that because these would all be multiples of each other. Okay? So this case is we have 3 planes intersecting in a line. Okay? So what we are going to do is we are going to express our infinite solutions answer based on the line that they're intersecting at. Okay? Sorry, but you don't like that I'm telling you that, do you? You want to just stop at infinite solutions.
I mean, it's right.
It is right. Okay.
So if we're right.
Well, when we have infinite solutions with 2 variables, we have the same line. Okay? Our equations are the same line. Here we have 3 planes intersecting in a line. Okay? So this is what you're going to do. We can't really write, well, you don't have the tools to write the equation of a line in 3 dimensions. Okay? Let's think about it. In 2 dimensions, we talk about y equals mx plus b. We talk about y-intercept. We talk about slope. We are in 3 dimensions. Do you know how to describe slope in 3 dimensions? We sure do not. Okay? So instead, what you are going to do is you are going to represent your answers in terms of a 4th variable. Okay? So you are going to say, you're going to pick a variable. My suggestion would be pick one of these variables in your 2 variable system. For example, z. I can say, all right, I want z to be the letter A. Okay? Basically, we're going to describe slope in 3 dimensions using the letter A. Okay? We're going to describe what each coordinate looks like on this line that they're intersecting at. Okay? So I'm going to pick z to be A. Which variable should we express next? X or Y? X, because it is in our 2 variable system.
Yep.
Okay. So I know that 4x plus 2z equals 10. So 4x plus 2z equals 10. So now we get to solve for x. So 4x equals 10 minus 2a. 10 divided by 4 is 5/2. Minus 2 divided by 4 is 1/2. So if z is a, x is 5/2 minus 1/2a. Now we need to find y. So what do you think? The first equation might be the best to use?
Yeah.
Okay. I'm going to go ahead and rewrite it. Will you read off that first equation to me?
2x plus y minus 32.
It's a 3z.
Crazy.
Oh, 3z, sorry. I can write that. Equals 4.
Okay. So we're going to plug 5/2 minus 1/2a in for x and a in for z. And we're going to solve for y. So we have, if I distribute that 2 through, we have 5 minus a plus y minus 3a equals 4. negative a minus 3a is negative 4a. I'm going to move it over to the other side to be 4a. And then we can take this 5 and subtract it over with this 4 to be minus 1. Do you agree with my algebra there? Okay. So while we do have infinite solutions, we can describe our infinite solutions as 5 halves minus 1 half a, 4a minus 1 a. Okay. So we can plug any number in for a, and it'll give us a point on that line where these three planes are intersecting. Yes.
So, we pick Z to be A here, but why just, like, what if you said X equals A?
Okay, if we let x equal a, then your answer would look a little bit different, okay? But it would still, as long as you did your algebra correctly, you would still get the same coordinates when you plug different numbers in, okay? So that is a good point. If you were to take this problem and let x equal a, your coordinate is going to look different because your a is your x instead of your z, but it's still going to represent the same infinite number of points.
So then, why do you even have to use an A and all? Why can't you just write it all in terms of Z?
Why can't you just write it in terms of z? I guess technically you could, but I think like using this a, like just as a third, like why don't I want you to do that? Because you're right. Technically, you could just write it in terms of z. Let's see if the book. I guess I don't want. I want you to kind of separate that, like when we have this a, it's representing all of the points on a line. You know what I mean?
It just kind of seems redundant to have Z equal A and then just what's technically with Z that A.
Yeah, I guess, like, I want you to use A so that, like, I can see that, like, this is an infinite, like, this is representing the different points on a line, okay? It's kind of, like, it looks different, so we're kind of just, like, separating it from Z is a part of our equations, you know what I mean?
So it's for the sake of the textbook writers to make their answers different.
And for me too. I mean, I want you to understand that this is still infinite solutions. We can plug anything in for A and still get like an infinite number of solutions. Okay, so we can write A is a real number. Okay. If you want to write everything in terms of X, Y, or Z, I'm probably not going to get upset about it, but
I'll still write it in terms of A. I'll read it why.
is everyone okay with how we're getting those three variables? Or right, those three coordinates? Okay, you will have a required problem in your homework that's going to be like this. Now, if you're checking your answer, and they let A be X, and you let A be Z, is your answer going to be the same as the back of the book? No. And does that mean it's necessarily wrong? No. Open your book to page 498. Not every single person has to have a book open, but at least have one or two on your table to where you can read the book.
Oh my God.
When you turn to page 498, I want you to read number 62.
What number did you say, 62?
Yep, it's written up there on the board.
In the title. Oh, 66. Yeah. 62, Jackson. What do you need?
Okay. What are we looking for? What are our three variables?
TV, what? Radio,
All right, Darby, if I let X equal TV,
number of television ads.
number of TV ads. I like that a lot better. Do you guys see the difference between X equals TV and X equals number of TV ads? There should be some sort of quantitative word that goes along with it. Okay? Y? Number of radio ads. And Z? Okay. We know a few things. We know that our budget is $42,000 a month. So what do we do with our $42,000? What do you say, Jackson?
Set it equal to the total of all of the costs.
Okay, so if this deals with money and how much it costs us to produce these, right? Then on the other side of the equation, we should also have costs. So how much does each TV ad cost? Okay. How much radio? How much for newspaper? Okay. So we used all of those two sentences. The department wants to run 60 ads per month. What do you say, Connor?
5 plus 3 plus 6.
We want a total of 60 ads per month. So X plus Y plus Z equals 60. And they want as many television ads as radio and newspaper combined. What do you say? X equals Y plus Z. Do you agree with that? Newspaper is the same as radio, or excuse me, TV is the same as radio and newspaper combined. Okay? So what I would probably do is I would rewrite that third equation. Okay? Our systems make a lot more sense if they're written consistently. So I would write this second one as X minus Y minus Z equals 0. Okay, that way you can clearly, you have all of your variables on the left side, constants on the right side, and then you can start picking and choosing what to solve. Okay. I am not going to go through the algebra of this, okay, because I don't think it's necessary. I think what's necessary is setting up the problem. In the end, we want to make sure we actually describe what our answer means. In a word problem, you're not going to give me a coordinate for an answer. You're going to tell me we need this number of TV ads and this number of radio ads, etc. Okay? What I do want to do is get back your midterms. So on your gold sheet, you have these problems. You can write them down or look at your gold sheet. It doesn't matter to me.